my name is Joel Dunai, and this is my official, unofficial network state exam solution. Now for the 28th topic, which is about the zone-based firewalls. And this topic is mainly really short. So it starts with the first bullet point, that zone-based solution, but before this we should introduce the firewalls and how zones have been evolved or developed. So how does it look like? First, of course, you can come up with the simple solution. I don't know how to write. Of course, it is really easy. Let's say this is the trusted network and this is the untrusted network. And of course you have to tell that the traffic that's originating from the trusted network to the untrusted network is by default is inspected, therefore it is allowed to return because it is inspected, and by default the traffic that's originating from the untrusted network, so from the internet to the trusted network, is generally blocked. We have the other approach when we have also a DMZ, a demilitarized zone, and that's quite simple, that we have the same approaches, I believe. So this will be the DMZ, the demilitarized zone, and simply if the traffic is originating from the trusted network to the demilitarized zone, it's generally inspected and allowed to be received because it is inspected, and the DMZ by generally is blocked to the trusted side. Meanwhile, the DMZ can communicate with the untrusted network and the untrusted network can communicate with the DMZ. For example, the DMZ can be an HTTP server that should be available. That's why it can be accessed by the trusted network as well, because they can surf on the web, for example, because the traffic can come back. So this is the simple one, and based on this we evolved to a new one where, for example, we have a trusted network, we have an untrusted network, and we have a router at the middle, and basically that's all about this. You don't have to say anything else about this. I believe I'm going to use this approach. So this will be a zone to me. Okay, zone. That's my help. So we can use zones, and what this means, that generally the advantage of the zone-based firewalls that everything is blocked, and that's good because by default everything is blocked. Only those interfaces can communicate which by default placed into the same area, or to the same area. Oh, come on, to the same area, or they have the same features within the area. By default, an interface cannot communicate with another interface that is in another zone. And of course here we have to mention something else, that this zone is special because this is called as a self zone. The router itself is called as a self zone approach because it's simply used for management plane, for management approaches, for example SSH, Telnet, and other approaches. So please don't forget the self zone is really important. So by basically, how does it look like? Because we have to here define the steps and the other stuff, so it's really basically really easy. Our first approach or first step is to define that which interface are belonging to a zone, and that's quite easy. We have to define the interfaces that we would like to be in a zone. The next step is to define a class map where we are going to define that what traffic we are going to inspect, drop, or allow. So a class map is the second one, where we simply define, for example, HTTP, UDP, ICMP or a services. So we just simply define what we would like to make available or not available, for example. The third approach is to define a policy map. For the policy map, we have to use the class map, and here we simply define that what we would like to do with the defined services, for example, drop them or inspect them or other stuff. It's up to the user. And of course, the fourth step is the last one, where we are creating zone pairs. And zone pairs means that this can be zone 1, this can be zone 2, zone 2, and we can do a zone pair with each other, where we have to define the zone 1, the zone 2, and we have to use the policy between the two zones. So basically that's all. We have to define which interfaces belongs to which zones. We have to define a class map where we define what services we would like to use or access or inspect, and then we have to define a policy map where we define what to do with the services, and fourth, we have to define the zone pair between which we would like to allow or not allow. So for example, we can do in this case a zone map, a zone pair with the trusted and the untrusted side. For example, we drop the traffic that goes, for example, if we switch it, that goes from the zone 2 to zone 1 will be dropped, for example, but we can do another that from zone 1 to zone 2 is inspected. So basically, let me check it. That's the design of the step, and I've told about the zone pairs, traffic, everything. I've talked about everything. So now I just have to tell what's the advantage of the zone-based firewalls, and it is quite easy that the zone-based firewalls are, as I said, generally block the traffic, because you have to define the zones in order to enable communication between the interfaces. So that's the first advantage, that generally or by default everything has been blocked. The second is that it's independent of access control lists, and you know that access control lists can be hard to configure or hard to administratively or maintained by the administrator. And the really advantage of it that it generates quite good logs, therefore the troubleshooting can be done based on its logs. So basically that's all about the zone-based firewalls. I believe I've spoken about everything, so this should be fine. Again, if I said something wrong, then I don't really care, and don't forget to subscribe.